The Battery Buzz podcast is brought to you by H.B. Fuller Company. H.B. Fuller is one of the battery industry's leading suppliers of adhesive, encapsulant, coatings, and sealants for the EV and battery industry. Hello and welcome to Battery Buzz, the show for battery professionals by battery professionals, keeping you connected to what's new with batteries and the people who help build them. Your battery specialist hosts, myself and Jermaine Maris Alvaraj, are back for our next episode. Now let's get started. So thank you for joining us. This week we have a very special guest, Jesko Thomass from Erwin Quarder. We're thrilled to have you, Jesko, on our podcast to share insights about what your innovative cold plate designs benefits are. And we're looking forward to engaging discussion and learning more about the unique approach Erwin Quarder brings to the table. Jesko, it's an absolute pleasure to have you with us. Welcome.
Yeah, thanks for inviting me and happy to be here.
Awesome. Yeah, no, we're excited. So Jesko is passionate about outdoor activities like hiking, mountain biking, and skiing, which is awesome. He also has a degree in mechanical engineering from the University of Cooperative Education in Germany. He has a rich background in software development to calculate energy efficiency and driver assistance systems. And with this experience, Jesko joined Simmons Industry Software as a pre-sales consultant. Then he went to Webasto as a thermal engineer, and finally here at Erwin Quarder in 2022. So where he's able to implement all of his compounded previous experience for this role. So I think that's awesome, and excited to have all the insights that you have about the industry.
Yeah.
And you have a very diverse background. It must be very interesting that you get to use all of these skills in one role. So that's probably pretty exciting for you.
Exactly. Yeah, it helps a lot. Also when it comes to batteries, and also when I started like 2017 at Webasto, you always need to have a complete overall understanding of the battery, not only thermal, but if you also understand a little bit like the electrical side and so on, it's always helpful. Yes.
I can imagine.
So, can you share a little bit about your company's history and what inspired you to focus on battery cooling plates and,
Yeah, of course. I would love to. So, we have to go back for more than 50 years. So I think Erwin Quarder, or not I think, I know Erwin Quarder was founded 1971. And it was founded by Mr. Erwin Quarder. Who gets this? That's also the company name. And he started to building tools, especially for injection molding. So we weren't or at the beginning, we didn't start building plastic parts. This started in 1986, by the way, the day I was born. And so we are mostly producing plastic parts for the automotive industry. And as it is typical for automotive, you will find us in all the regions. So the headquarters in Germany, in Espelkamp. So that is where it all started. But we are also in Czech Republic, in Asia, and also in Mexico and the US. And I'm currently here in the US. I'm talking to you out of Grand Rapids in Michigan. And we're doing innovative plastic parts. And what you told me, Elizabeth, is how did you came to this special technology we have, this hybrid bonding technology? And I have to say, you said it at the beginning, I was just there 2022, I joined Erwin Quarder, but it already started further. So I run a little bit around the company and ask hey, how did it start? And the story is quite interesting. So something around 2017, a big cell manufacturer worldwide was coming to us. And they were asking can you build us a plastic injection molded housing for a 48-volt battery? And so what happens is mostly you get your RFQ, you start designing a little bit, you check it. And what they also wanted to have was they want to have an integrated cooling plate into this battery housing. And during this time, we looked for the standard solutions you could have on the market for cooling plates, and we integrated. We made our cost breakdown, and what do you think? It's coming to automotive, and it was too expensive. And one of the most expensive parts was the cooling plate. So my colleagues before, they start to investigating to get like new technologies or like to get the costs down. And I said like, okay, maybe we have to think and we have to look a little bit further and start a development. And you have to say, we investigated a lot of things. We are looking like for overmolding like aluminum parts, but then we have to find out, hey, they wouldn't secure lifetime tightness for the automotive requirements, for example. We looked on several coatings. We looked like just screwing it using like EPDM sealings, like O-rings and so on. And it was quite challenging. And then one of my colleagues, he fell over research. And it was a research of the University of Kiel. And they did some very special surface treatment. And it was the so-called nanoscale sculpturing. So they can create like a very special surface, especially on aluminum surfaces. And we thought like, hey, maybe we have to investigate it, because when you're using like thermoplastics, the good point is you can heat them up again and melt them again. And we were just wondering like, is it possible to melt like an injection molded part again onto the surface and maybe it will flow into the surface? So the internal development was starting, and we just tried it out with some prototypes, and we had to say the results were very outstanding. Sorry, that's the right word. It was outstanding because it was not only watertight, it was already helium tight. And that was the story, how it started all up. So like from this kind of like just in housing with a cooling plate, and then, having a problem with the pricing and looking on the market, finding a new solution. This is how we started building several types of hybrid joint cooling plates.
Yeah, that's really interesting. And it's also I love the innovation that you guys did to get to where you are now, and hearing the story about what drove it. And I think everybody can understand, in today, 2025, how pricing is king.
Exactly. Yeah. That's the point.
What's funny is as you were talking, I was like, there's weirdly a lot of similarities, I feel like, between Erwin Quarder and H.B. Fuller. First off, company is named after the person who started it, H.B. Harvey Benjamin.
Very good.
Global company.
Sorry, you have to help me. What is H.B. again for H.B.
Harvey
Fuller?
Benjamin.
Harvey Benjamin.
Our forefather. Yeah.
Very good.
Yeah.
I'm not sure if everyone knows about this.
Yeah. But you know what? That'll be on the test at the end, Jesko. Just write that down.
Perfect.
But it's funny you mentioned that, cold plates wasn't really what you started in either. And neither was H.B. Fuller. We didn't start in adhesives. We started in something else. And then we just took the path of what we needed to do. And now we're adhesives, and now kind of the cold plate innovation. So I thought that was so cool.
Yeah. Didn't we start with scaffolding?
Yeah, it was like wallpaper scaffolding, and we had a patent on it.
Yeah. Not even close to what we do today.
Yeah, right. At least, yeah.
Was it the glue for the wallpaper or just the wallpaper?
No, just the scaffolding. Yeah.
That's so weird.
But tell me, how long does H.B. Fuller exist already? It's more than the 50 years of Erwin Quarder?
Yeah, it's like 100. I don't know. I don't remember the year. Do you?
Right.
It's over 100 years old. So we're
okay. That's quite a lot. Yeah.
Yeah.
Then we're still young with our company.
Yeah, you guys are,
Yeah, who knows? Cold plates might just be the starting point, right? That might be your scaffolding.
Who knows? I know.
I mean, there are also plenty of options. I mean, I know it's kind of battery bus, but it's not only cold plates what we are currently investigating. There's also like a cell pole sealing or power electronics cooling. So at the end, I'm saying like thermal management is always like the holy grail, kind of. You want to make everything much more smaller, put more power density into it. And at the end, you have to add cooling systems in it, just look on your consumer electronics, like also your laptops. They are also full of a thermal management system, to get it done. So I think there will be a lot of more things coming up.
Yeah, exactly. That's such a good point that you made, Jesko. And that kind of leads me into my second question, because you had kind of started, this journey had a little bit started when a customer came to you in 2017, and then you kind of knew the power of thermal management. And you kind of talked a little bit about what makes you unique with like the lightweight, kind of the remelting, and having that all perfectly sealed.
Yeah.
I guess, is that technology that you have still unique in the market right now that you're seeing, or are you kind of seeing other people trend that way as well? And like, what are you doing that's kind of putting you apart?
Yeah, I mean, it's a patented solution right now, which is very special to Erwin Quarder.
Sure.
And
That's
so it's especially this bonding between the plastic part and the aluminum plates to build like heat exchangers. So this makes it us very special. And yes, I mean, it has several benefits. Yeah, you know, if it, like, as you said at the beginning, yeah, not only being lightweight, but yeah, also you can get a lot of, or you can reduce a lot of costs, for example. Yeah. What I have to tell you also, when I was joining the company in 2022, I mean, you said it right. I was worked former also like as a thermal engineer, especially like for batteries. And what I was often super interesting on the one hand side, but also very challenging is like, if you have to build like heat exchangers or thermal systems, you really were limited to the manufacturing methods. You know, you could have like extrusion profiles, then you mostly have the one direction where you can design something. I mean, you can use like stamping parts, for example. Then you have another direction, but it was still always difficult, you know, like guiding the flows through the cooling plates. And, you know, often there were areas where you said like, I couldn't guide my coolant there, you know, and then you had some hot spots in the batteries or whatever. And when I came over there, and especially it was a reason because it was a private reason for me also to move location. And then, of course, I was looking for jobs, and I was looking on the Erwin Quarder profile and the job description. And then I was just looking on the websites, and like, wow, that's super cool. You know, it's like plastic injection parts, and you have like several channels in series, in parallel. You know, I can just add some flow guidance, for example. And it's like, wow, it seems like it's a solution for all my problems I have right now. And I applied for the job for them, and yeah, luckily they they hired me because we had a lot of to exchange. You know, I can learn a lot about its technology. And yeah, and I also brought some knowledge back, yeah, from my thermal management background in this case.
Yeah, that's interesting about the flow. You said there's like certain areas where you can't get the coolant to flow within the cold plate, the limitations there. I wasn't aware of that. So what is that challenge?
And I mean, often like, for example, you know, when you're on a battery, let's start from the beginning. You have like connectors, maybe on one side. You have the inlet and the outlet. So maybe the coolant has to go in a U shape through the battery cold plate. And also coolant, I think it's a typical physical problem. You know, everyone is lazy. Also coolant is lazy. So it always tries to go to the shortest way through the cooling plate. So a coolant will never go like up, go in the last edge, go back and go forth, or it will still try to, oh no, just shortest way, and that is it. So what you have to do, you have to put like something into your cooling plates. You have to put like fins in it, guiding fins, or like some dimples, whatever, to really force the coolant to go in every edge. Because it's interesting, our cars are still like, I would say, still rectangle. Maybe we should make them round, but I don't know if someone will will buy them then it would be easier. But as they are mostly rectangle, you know, then you really have to guide it into the edges of the batteries. And yeah, this is always challenging. And
that's interesting because you think everything's so simple, just put some fluid in it and it'll flow everywhere. But I never thought about you have to direct the fluid and put, you know, in it to get it to go to the edges. Yeah. That's interesting.
I mean, there's also one point about it. I don't know if you know it, but like a lithium-ion cell, mostly the nominal voltage is about like 3.6 volts. But the cars mostly have like 400 volts or like going up to 800 volts. And so what you have to do, you have to put like all the cells in series. So the problem is now if just one cell, for example, gets too hot, then the internal resistance increases over lifetime, or like the capacity goes down. And that will influence the whole efficiency of your battery or the whole performance. So the point of if it's just one cell, which is not fully, or which doesn't have like a good thermal management, it can impact the complete battery. And that is why it gets so interesting to get all the flow through the cooling plates and really cool every cell in a battery very, very efficient. Yeah.
Yeah, that makes a lot of sense. It's a lot of stuff that I took for granted. Like you said,
I
Elizabeth, I
know.
never even thought. I was like, yeah, fluid.
Anybody can make a cooling plate, you know?
Yeah, thermodynamics and fluid dynamics. That's very cool.
Yeah, that's also interesting. I mean, also when I started like in 2017, I mean, I came to the business or for like thermal management like around 2017. I mean, there were some players on the market, but it's just started a little bit, I have to say. And yeah, it was also completely new for me. We had like also like requirements which were super tight and everything. And I mean, I have to call my suppliers, like you guys, you know, calling you and saying like, hey, I need this kind of cooling plate. I need like 3 kelvins of maximum temperature spread over my cooling plate. And every supplier was just like, oh God, how shall we do this? Where are these requirements are coming from? But at the end, it also was coming from because you started really new. You're starting like from a green field. Nothing was there. You just have to start and build some cooling plates. Yeah.
So I think it'd be interesting, like from your perspective, what would be like if I was coming to you and look, if I was looking for a cold plate, what are some key things to look for, to ask about? Because I mean, like Jermaine and I were not even knowledgeable about fins and the, forcing the fluid to go in the
Yeah.
corners. What would be some other key features or that we should be looking for when looking for a
Yeah.
cooling plate?
There's one interesting fact about, and I think it often comes to the usage or of like the power cycle of your battery. I think there's still something you have to think about it a lot. I mean, often, yeah, our customers are coming to us and say like, okay, just do it for the fast charging, because the fast charging for a battery or to create a cooling system, that's the worst case. But I also saw during these years I'm working for it. So for how long you look on the fast charging, if you're looking like, for example, from 20% SOC, maybe, I don't know if everyone is aware of SOC, it's a percentage you often have also on your mobile phone. So it's the state of charge we have. Are you looking like for 20% SOC to 60%, or is it just to 80%? Because often it also happens like if you go like to the higher like SOC states of a battery, then the requirements for the cooling falls down. So sometimes it can be, if you're just looking on a full charging cycle, it isn't that worse than when you're just looking, for example, charging from 20 to 60, going down from 60 to 20 and back. And here, this is what I also said at the beginning, to also have a kind of like system understanding, how everything works together is, from my point of view, very important. As I said, also when it looks a little bit into the cells, then you have like different internal resistances. They can vary between the temperatures. If I'm looking for my cooling system on very high temperatures, like at 100° Fahrenheit or something like this, do I looking also on cooler temperatures? So you still need a good understanding. And then what I also said, also at the end, it is like, how will you use the car? Will you like create a sports car, which is like driving on a racetrack, then will be fast charged for 20 minutes and then go back on the racetrack, versus maybe just a family car where you, I don't know, driving like every day your children to the kindergarten, for example, which doesn't need so much cooling performance in this case. I mean, this is something, I think that is all where it starts. So you really have to be sure about what is the use case of the battery, and what is like the worst case for the cooling plates.
Absolutely. I think that's such a good point. And I think, you and us as well are super susceptible to that, right? Like the thermal management aspect of the use case of the batteries are so different, but also I think one of the most important parts in terms of like the adoption of EVs, right? Is that if you can make a battery that is safe for all these different use cases, then only I think
Yeah.
it increases the adoption of the vehicles or the use of the batteries in general. You're kind of very intimate with that trend and to some degree so are we. So that's super interesting. I agree.
I mean, what is also important, I mean, on the one side is it's the performance. I mean, I think every consumer at the end wants to have his full charging power under all circumstances in winter and summer, even if you charge like 4 times after each other. But it's also thermal management, especially with batteries, also comes to lifetime.
Yeah.
So it is important, I'm pretty sure no one just wants a car which works like 2 years. I mean, this is still not acceptable. I mean, we were talking in past years, that you get like warranties for 8 years on your batteries. But as an engineer, I still say to myself, no, that's still not enough. I want to have my 15 years, what I normally get, also for my cars. And
Yeah.
thermal management will help. It will really help, keep the batteries in a certain temperature, that they last longer, that you can use them much longer, and maybe even more like than the 15 years, just keep the capacities of them very stable over this long time.
Yeah, and I think it's challenging meeting all the different scenarios. I think, that people operate vehicles, and just batteries in general. So I think that we find it challenging ourselves. Like we end up creating families of products to help with the vast array of usages and performance, and that we can get out of our materials. So it's an interesting challenge, I think, that we face. And
Yeah.
I think, going into energy storage systems and other, battery systems, we'll have to pivot to meet those needs too. So
Yeah.
I think it's exciting world. And I think in 2025, we're going to start to see a lot more, scenarios of battery usage.
Yeah, exactly. And also the requirements. I mean, also when I talk like with friends or with family, and often I tell them like, I'm just making like heat exchangers. I also like to talk about heat exchangers. I mean, we can cool, but we can also heat. But I am still wondering why no one wants to heat his battery, but maybe it's not necessary anymore. But there's also more. It's not just a heat exchanger, and I think you also know it, Elizabeth. There are requirements, for example, regarding dielectric strength. Then you have to put some coatings on it, or you have to make sure that during a malfunction within the battery, you have to make sure that still everything is in place, and that no one, for example, gets hurt. And all of these requirements coming together, it's not just only cooling a battery. It's really much more. It provides the complete safety of the battery.
Yeah, that's a great point. And I think the other key challenge that I think we have is educating, people on the batteries themselves so they feel more comfortable, adopting the EVs in their daily lives. So that leads us to our next topic. That's beautiful thinking.
Yeah.
The challenges and benefits of educating our consumers about, this lithium ion technology and sustainability. And I know like last year, I think we all felt it, that we saw like EV sales are not what we expected. And a lot of key players, decided to either eliminate or reduce their programs. So I think what challenges and benefits do consumers need to know more about to make an educated decision regarding EVs? And I think that it was the demand for these vehicles that really impacted 2024 and the rise and fall of the EV. We were supposed to be on a trajectory up and we ended up, coming back down. So I'd
But
like
was
to
it like
get your,
this,
I'm
Elizabeth?
sorry.
I heard, or I just read some statements, especially also in the US, that the EV sales were pretty good. Yeah,
Yeah,
what
I
also
think
kind of a little bit surprised me, but I mean, I'm super happy about it.
Yeah, I think there are some companies that did really well. I mean, Tesla, I know they did really well. I know that I think we saw it within our industry from the material side of things.
Mhm.
There was a little bit of a dip, but I guess
All right.
I'd love to hear your perspective on that.
Yeah. I mean, it is still currently challenging a little bit, I have to say. Um, I want to start a little bit different. You also said at the beginning, yeah, maybe what can we do? You know, like also bringing like people more to electric vehicles. And I think I was driving a lot of electric cars. I
Mhm.
have to say in my life, and I really like them, and I super enjoy them. They're super cool cars. But I think I also like them because I have a little bit like insight into electric vehicles. I know how they work.
Yeah.
I know what is inside. And I'm just saying this, but I think, you know, everyone wants to be a little bit proud of his car and maybe also wants to show off a little bit with his car. But just
No.
imagine, no, I think, just
No, I
imagine
agree.
you're sitting in a bar with your friends, you know, and then they're asking you, hey, what's so cool about your electric car? I don't know. Most of the people, they cannot tell you anything about it. And what is sometimes interesting, I'm also start stirring up people a little bit. And I said, like, hey, do you read it? It was like the new Honda Prologue. It makes 130 miles to the gallon. And then they're looking at me and like, what? What are you talking about? 130 miles to the gallon? I said, like, yeah, you know, just take a gallon. And imagine the energy is stored, which in this gallon, you put this in an electric car. Then this electric car can go like 130 miles with 1 gallon of energy. And then they're asking you, like, hey, but why? They're like, yeah, it's a pure efficiency of the powertrain. You know, we're talking about like 80% or something, you know, just roughly give it up. And I think like a combustion engine, maybe just a 40. I mean, to be very on the positive side with the
Yeah.
40%, you know, that's the point. And saying like, yeah, but it's 40/80, it's still not 40 miles to the gallon to 130. You say like, yeah, you know what? But I get 65% or 64% of my energy back. And they're asking me, huh? How do you get it? It's like, yeah, it's because of recuperation. You know, I go from battery inverter to electric motor, and then electric motor inverter battery. You know, so I lose 2 times 80%. So I have to be fair to you. It's just 64 I get back. But you know, look at
Mhm.
this, how far I can come. And if you're just saying, and then you're telling them, you know, so I driving like in 2017 an electric Golf. If you just recalculate it and you tell them my car just had 1 gallon of energy in it, and I was driving with this through the whole country, driving over the Alps, driving to Italy, they are often saying like, what is this guy doing there? You know, it's like,
I know the way you put it, it's quite impressive.
yeah, you see.
Yeah.
So the point is, in my perspective, a car is an absolutely emotional product.
Uh-huh.
That's it. And if you cannot raise emotions in people, then that's a big issue. You know, if they're just buying it and saying like, "Hey, I have no clue what is in there," that's super far. That's super hard. And I think it's also like what the people saying like, you know, I do not want to go with it. So if you could start a little bit, telling them a little bit, what is in there, what is working. You know, if they turn on like the ignition and they heard these small like clack, clack, noises, you can say like, yeah, that's your safety feature. It's like the isolation switches. You know, they make sure your battery is completely coupled off when your car is parked, so nothing happens and so on.
Yeah,
And
that's really interesting. And I think the other thing, I mean, to that point is like the maintenance on an electrical vehicle, like, getting your oil change every month or every whatever it is. I don't know. Every 3 months. I don't know, every however many miles. I'm taking really good care
Elizabeth
of
has
my
never
car
changed her
right.
oil.
I have an app and it tells me to change my oil. um, so this is not looking good upon me. But but I mean, even like just maintenance, daily, maintenance of your vehicle. I mean, I think tires are the main thing that need to be changed on electric vehicles. So that really reduces the overall cost. So if you look at the overall
Yeah,
cost of ownership, the repair and parts, and it's more software really,
yeah,
software updates that needs to be done. So I mean, I think
yeah.
that's a key benefit there from you know, using the normal, ICE engine.
Yeah, that's right.
Yeah.
I mean, what I also I often, when I had electric cars, I let my friends drive, and they were always they were surprised, and they really say like, "Wow, that's such a nice car! It's such a nice feeling about it." And I know there are still some concerns also about electric cars. You're also talking about like challenges, Elizabeth. Um, of course, there are often safety concerns coming also up with electric cars, which I can fully understand. I mean, on the one side, I have to say, like, this technology, everyone has in-house. Maybe everyone is sleeping next to this technology already while charging, because you already have it like in smartphones, and they work like perfectly well. I mean, and often people coming to me say like, yeah, but if something going wrong with my smartphone, I just threw it out of the window. And I understand, yes, that's a little bit harder with a car. You cannot just simply throw it out of your garage. That's and there's a lot of energy stored in it. But what also often helps when I'm talking to friends, family, people I know is like, sometimes I'm just explaining this, what we are also doing here as engineers. And I just want to bring it also like in mind. It's not like that. So the electric cars are at least like built and designed like a combustion engine car. And I would say like there's even more requirements, standards we have to fulfill to make it safe. So it is not that all the OEMs, and I'm speaking here worldwide, doesn't matter which OEM, is like coming and saying like, I will just bring out a car and I don't care about safety. I think it's the complete way around. They are really aware of safety, and they do a lot of work. And when you're telling them, what we're doing here, we're doing a lot of testing, and they're so interesting testing. Sometimes you have to see like there are fuel fire tests, there are crash tests, there are crash tests. What we're doing like, especially here on a component level, like the torch and crit tests, going like with a 1000-degree flame with gluing particles or materials, just to make sure that in a case of a malfunction of a battery, everyone is safe. They are doing a lot of work, and I really have to speak for the engineers here all worldwide. I have to say, they're really doing a good job, and they really want to make sure that the cars who are on the way and on the streets are super safe. That's always our highest goal.
Yeah, and I think there's a lot of people. I mean, they're very passionate, and I think the three of us are very passionate about batteries and electrical vehicles and just electrification in general. So I think that we work really hard to create materials that are safe, that help engineers build safe materials. So there's a whole network of a community just trying to achieve the best technology using
Yeah.
what we have. So I think that's really important.
Yeah.
Yeah, I
And
totally agree. I think that transparency kind of really just helps brands, kind of it builds that trust that I think a lot of these, the internal combustion engines, all that has for decades and decades, which obviously, right, is they're coming in kind of as the underdog in that way. But I think that's how you get to that level, right? You kind of personalize it, like you said, Jesko, because right now it's a little bit of a black box. Like electric vehicles are great. Okay, why are they great? Well, because of this. But kind of getting into the details of it, I think, is really how you build that trust and transparency, and kind of builds the loyalty, I'd say.
Yeah, that's right. I mean, I also have to say, like, I'm not so good in English, I have to say, but it's also saying, like, you see today and you harvest tomorrow, kind of.
Mhm.
I mean, I'm pretty sure there's still a lot to do also with electric cars, and there's still a lot of things which are not perfect right now. First of all, that's my job. I have to solve problems. If there wouldn't be problems on the world, I wouldn't have a job. So sometimes I'm happy about problems. But on the other side, I know that maybe things are not good currently. Maybe where you get your supply chains, where are the materials coming from, what you often hear also from consumers, and they're like, hey, maybe it's coming from mines which are not, where people work like under not good conditions and so on. But if you're starting like now and getting into this more and more, and also people start like, hey, I believe in this technology, I know it's not perfect right now, and you start rolling the stone a little bit, then also like all the OEMs, and they're doing it, and they will improve every process, supply chain processes, safety processes, and so on. And when I see what is coming up, also like you can just look for research for batteries, for new cell technologies, for safety materials, whatever is out there, is super. How can I say? I'm super convinced, and I really see that there's such a big potential in this technology. And sometimes also talking to my colleagues and say like, hey, wait 5 years, and we will complain about the range of combustion engine cars because it's so low. It's like,
Yeah.
because
I really think that's where we're going. Yeah.
yeah, exactly. And also when you look on the energy density you have, so like lithium ion, the lithium ion technology, whatever it is, if it's like an NMC, an LFP, you know, IBM was looking on lithium air, and I think a lot of research is done on this. You could get like much more energy output out of a battery than you will have now with a combustion engine. So it is just a matter of time. And I think we just have to be also a little bit patient. And from my perspective, you also do not have to convince people driving electric. You know, I also learned in physics, the higher the pressure, the more the resistance is. So if you just like, yeah, I mean, if you're just saying like, hey, drive all electric, no, I mean, it will not work. You know, people start like to adding a little bit back and saying like, hey, I do not want to. If you just let it like a normal flow and the technology improves and improves with every year, people will see it, and I think they will enjoy it in the upcoming years. That's what I'm pretty sure about it.
I agree
Yeah.
with you. That's a great perspective to have, I think.
Yeah, I think with every kind of new technology that comes out, right, there's always that initial pushback.
Yeah.
So yeah, I think now we're kind of probably going to get into like the slower rate of rise, maybe, but I think it'll be sustainable over years and years and years, which is what we want to see.
Yeah, exactly.
Yep. So that's all the time we have today. Unfortunately, great conversation. Love the insight. So thank you for joining us. And next month we'll have another episode of the Battery Buzz podcast, and we'll be having a special guest also join us to discuss more things on everything battery. So thank you, Jesko, for being here and
Yeah, thank you
joining
so
us.
much.
Yeah, it was a pleasure. Really enjoyed it.
Well, thank you. And like Elizabeth said, that's all the time we have. So if anyone has any comments or questions on today's discussion, feel free to comment and give us your insights. So, and with that, please subscribe, like, and follow us, and check out our electric battery adhesives page on LinkedIn. So thanks, everyone.
All right. Thanks.
Bye-bye.